Okay, so you want to own a rocket company. Build a giant machine out of metal and fuel. Point it at the sky, light the engines, and hope your billion-dollar investment does not turn into a very expensive fireball before it reaches orbit. It sounds like the worst business in the world. Every product you sell is traveling faster than a bullet, carrying explosives, and operating in an environment where one small software error can destroy years of work in a few seconds. Your factory is enormous. Your customers are governments and billion-dollar corporations, and your delivery system is designed to disappear after one use. Here's the strange part. Rocket companies used to make money by building a new rocket for every launch and throwing the entire thing away. Then one company started landing the most expensive part back on Earth, and the economics of space quietly changed forever. By the end of this video, you'll know what it costs to build a rocket company, why one launch can cost tens of millions of dollars, how reusable boosters change the profit equation, and why even a rocket that launches successfully can still lose money. Rocket companies come in three sizes, and they are three completely different businesses. At the small end, you have the dedicated small launch company. It builds rockets designed to carry small satellites into orbit, often for governments, universities, and private companies. The rocket may cost tens of millions of dollars to develop, and each launch can sell for several million. The customer is not buying a seat on a plane. They are buying a direct trip to a specific orbit on a schedule the operator controls. Then there's the medium lift launch company. Its rocket carries heavier satellites, cargo, and sometimes astronauts. Developing this kind of vehicle can cost hundreds of millions or billions of dollars, especially when the company is trying to recover and reuse the first stage. And then there's the giant, a company building heavy lift rockets, satellite networks, lunar systems, and spacecraft at the same time. At this level, you are not just selling launches, you are building an entire space infrastructure business, with factories, launch sites, ground stations, satellite fleets, and government contracts. The rocket is only the visible part. Before the first launch, there are two costs that can destroy the company completely. The first is development. A rocket company can spend years and billions of dollars before earning meaningful revenue. Engineers have to design engines, fuel systems, guidance computers, communications hardware, heat shields, launch towers, and software that all work together perfectly. The vehicle must survive vibration, extreme acceleration, freezing temperatures, enormous heat, and violent pressure changes. Testing one component is expensive. Testing the complete vehicle is even more expensive because every test uses hardware, fuel, workers, and time. And a failed test does not just cost money, it can delay the entire business for months or years. The second cost is infrastructure. Rockets need launch pads, fuel farms, tracking systems, clean rooms, factories, test stands, safety zones, and specialized transport. You cannot simply build one in a garage and drive it to a runway. A launch site can cost hundreds of millions of dollars. A modern rocket factory can cost just as much, and even after the building is finished, the company must maintain the equipment, whether it launches once a month or not at all. Now we get to the question that actually matters. Where does a rocket company make money? The obvious answer is the launch fee. A customer pays the company to carry a satellite into orbit. Depending on the rocket and mission, that fee can range from a few $1,000,000 to well over 100 million. But the launch price is not profit. The company has to pay for the rocket hardware, engines, fuel, technicians, insurance, range fees, transportation, testing, mission control, and years of engineering behind every flight. If the rocket is used only once, the hardware cost is enormous. For decades, that was the basic model. Build the rocket, launch the rocket, lose the rocket. Imagine running an airline where the plane crashed into the ocean after every flight. Even if passengers paid a fortune for each ticket, the economics would be terrible. That was space launch. The industry could improve engines and manufacturing, but every mission still required a new vehicle. Then reusability changed the calculation. A reusable rocket does not make the entire launch cheap overnight. The company still has to build the rocket, inspect it, refurbish it, replace some parts, and recover it safely. But the most expensive section, the first stage booster and its engines, can potentially fly again. A used booster might cost far less to prepare for another launch than building a brand new one from scratch. The cost of fuel is relatively small compared with the cost of the vehicle. The real prize is the hardware that used to be destroyed. This creates a powerful difference between average cost and marginal cost. The average cost of developing and manufacturing the rocket can be enormous. But once the vehicle exists, the additional cost of flying it, again, may be dramatically lower. That means a rocket company that launches frequently can spread its development cost across many missions. Frequency is everything. A rocket sitting in a hangar is not an asset producing revenue. It is expensive equipment waiting for a customer. The company needs a steady launch schedule so factories remain busy, crews stay trained, and infrastructure is used instead of sitting idle. That is why satellite constellations are so valuable to launch companies. A single customer building a network may need dozens or hundreds of launches. Instead of finding a new customer for every mission, the rocket company receives a pipeline of repeat business. The most powerful rocket company may even become its own best customer. If the company operates a satellite internet network, it can launch its own satellites. The launch division still has costs, but the broader company captures value from the network subscriptions, data services, and communications revenue after the satellites reach orbit. This is a major advantage over a pure launch provider. A pure launch company gets paid once when the rocket leaves the pad. A vertically integrated company may earn revenue for years from the hardware it launched, but vertical integration also requires far more capital. You're no longer just building rockets, you're building satellites, ground stations, software, customer terminals, repair systems, and a global network. The launch business becomes the foundation for a much larger bet. This is where government contracts enter the story. Governments are among the most important customers in the rocket business because they need secure access to space even when commercial demand is weak. Military satellites, weather systems, navigation networks, scientific missions, and human spaceflight all require launches. Government contracts can provide stable revenue, but they also come with strict requirements. The company may need to prove reliability over many flights, maintain backup systems, comply with security rules, and accept launch schedules that change for reasons outside its control. A government customer may pay a large contract value, but that does not mean the company can spend freely. Delays, testing problems, and redesigns can eat through the budget quickly. And then there's insurance. A rocket failure can destroy a satellite worth hundreds of millions of dollars. The launch provider may not own the satellite, but the customer expects protection against that risk. Insurance premiums depend on the rocket's history, the mission, the orbit, and the value of the payload. A company with several failures can become more expensive to insure, which makes its launch price less competitive. One spectacular failure can damage sales long after the flames disappear from the launch pad. The most famous example is the Challenger disaster in 1986. The space shuttle broke apart shortly after launch, killing 7 astronauts, and revealing how a small engineering failure could become a national catastrophe. In 2003, Columbia disintegrated during re-entry after damage to its heat shield. 7 more astronauts died. These disasters were not private rocket company bankruptcies, but they exposed the central risk of spaceflight. A vehicle can function perfectly through launch, orbit, and most of its mission, then fail during the final minutes of coming home. For a commercial company, the damage is financial and reputational. A failed rocket means lost hardware, lost customer payloads, investigations, delays, refunds, and future customers wondering whether they should trust the next launch. And not every failure is explosive. A rocket can reach orbit, but place a satellite in the wrong position. It can deploy the payload late. A software problem can interrupt communication. A small technical issue can turn a successful launch into a failed mission from the customer's perspective. The company may have to pay penalties or provide a replacement launch, while still paying the cost of the original attempt. This is why reliability is more valuable than a dramatic launch video. Customers do not want the cheapest rocket. They want the rocket most likely to deliver an expensive satellite exactly where it belongs. Now, consider the competitive problem. Reusable rockets can lower costs, but they also create pressure on every competitor using expendable vehicles. A company that throws away a booster after every mission has to charge enough to replace it. A reusable competitor may be able to offer a lower price while still earning a margin. The weaker company then faces an ugly choice: lower prices and lose money, or keep prices high and lose customers. Some governments may continue supporting domestic launch providers for strategic reasons. A country may pay more for its own rocket because it does not want to depend entirely on a foreign company that keeps competitors alive even when they are not the cheapest option. But commercial customers usually care about price, schedule, orbit, and reliability. If one provider can launch more often and for less money, it captures more of the market. That is why launch cadence matters so much. The company that launches frequently learns faster, reuses hardware more often, and keeps its fixed costs working. The company that launches rarely has fewer opportunities to improve and fewer missions over which to spread its expenses. Now imagine two scenarios. Scenario 1 is a small dedicated launch company. It spends hundreds of millions developing a rocket designed for small satellites. Each launch brings in several $1,000,000, but the vehicle is mostly disposable. The company needs a high launch rate to cover engineering, staff, insurance, and facilities. If the schedule is full and failures are rare, the business can grow. If launches are delayed or customers move to rideshare missions on larger rockets, the company may burn cash for years while waiting for the market to improve. Scenario 2 is a reusable medium or heavy lift company. Development costs reach billions, but the first stage can fly repeatedly. The company signs government contracts, launches commercial satellites, and perhaps uses the rocket for its own satellite network. At high launch volume, the economics can become extraordinary. The vehicle is no longer a one-time product. It becomes a reusable machine that earns revenue repeatedly. But if development takes longer than planned, or the rocket fails during testing, the company may spend billions before earning enough to survive. Same factory, same engineers, same market. The difference between a space empire and a bankruptcy filing can be one successful test campaign. That is the actual economics of owning a rocket company. It is not a business about selling rockets. It is a business about selling access to orbit, repeatedly, with hardware that used to be destroyed after one flight. The rocket itself is only the entry ticket. The real money comes from launch frequency, government contracts, satellite networks, data services, and the ability to turn one vehicle into many missions. Build an expendable rocket that launches twice a year, and you own an expensive engineering project with a sales department. Build a reliable, reusable rocket that launches constantly, and you own something much more powerful, a transportation network to the most valuable real estate humans have ever discovered. But get the engine design wrong, miss a contract deadline, lose a customer's satellite, or spend too much money before the first successful launch, and you will learn the oldest rule in the space business. The rocket only has to fail once. The company has to succeed every time.